Okay, there we go. Okay, so let's get rolling. First things first, for Jordan, I'm Mr. Englot, and we'll be doing pre-cal here. It's it's can be a tough class a little bit. There's a couple of weird things in it, but for the most part, if you work at it and do your practice, you usually don't do too poorly in the class. So I'm going to shrink my notes down here, and I'm going to bring over this screen here with the outline on it here. Okay, so this is our class outline here. Now you'll notice that I've got it 60-40 here, exams more than hand-ins, but I think I'm going to do, I got to turn that on for you guys. Sorry. I forgot to turn on the projector here. I'm going to probably go 50-50 this year, just so it's a little bit easier. There it goes. Is that on?
There's a light blinking.
There it is. Okay, so there it is. So first unit there, if you look at, so we'll probably do 50-50, right? Rather than 60-40. So the first one we're going to look at is trigonometry, graphs, and the unit circle. That's the very first thing that we look at. It's one of the larger units for us. This is on your Google page, so you don't have to write it down if you don't want to, but you can write it down if you like to. Okay, and that's 20%, so it's a fairly large unit. Trigonometric identities is a really, there's one hand-in Unit 1 and one quiz. Unit 2 is trigonometric identities, a very weird type of unit. We're talking about identities being things that are, this math equation equals this one, and then manipulating them and things like that. It's a small unit. I only put 10% stock in it. And usually what we do there is we are looking at maybe one hand in there that we have. Okay, third unit is functions and mathematical transformations.
It doesn't work for him for math, but does that be the next option? So we'll figure out math.
Okay.
So Ben, what do you think? You're online right now, so
Yeah, it'd probably be better if you did phys ed.
probably better off phys ed right now.
Yeah, because we have two other guys that are doing it as well. Yeah,
Okay.
that'd be his better choice, I think.
Yeah, so you can go for some promotions.
I'll have more time next term, for sure, to do math with him. Sorry there, Jordan. Okay, so function operation and mathematical transformations. Function operation is when you use f of x, g of x, that kind of thing. And then we do polynomial functions. So polynomial functions would be, cubic equations like we did in Math Foundations 30 and things like that. Cubic equations, squared equations, quadratics, and lines and things like that. And then the last thing is logs. Okay, so these ones are fairly even, 15% apiece. Okay, each one of these has a hand in, all 5 of these units. Unit 2 probably won't have a quiz on it. We just do a hand in that one. And then we do a final exam that's kind of the whole class at the end of the term. So you've got 5 hand-ins and 4 quizzes and 1 final. And that constitutes your mark. And I think we're going to go 50-50 rather than 60-40 because we have a small group here and there's not a big pile of people in one school there that we have to worry about. So that's how that'll be. And I'll post all those things on the Google page, just like this video. So we're going to get started today. I'll just leave that up for a few minutes. You don't have to really write it down because we're going to end up with that put up on the Google page. Okay, so you can always look at the Google page there as well.
I don't think I'm supposed to be here.
Well, are you taking pre-cal 30?
I thought
You should probably be doing the phys ed like Ben in first period.
I don't think I was doing that either.
Check it out with Mr. Schwaga there. Okay, so let me move this back over, or is that, should I leave it up there for a bit yet? Leave it there for a bit? Okay.
Okay, you're good.
Okay, we're good? Okay, so we'll slide this over. We'll get my screen back up here. Whoops, that's not the one. That's the one. Okay, so the first concept that we're going to do is we're going to look at, the very first thing we look at is angle measures. So we're going to look at the two angle measures. This is something that you would have seen last year in Pre-Cal 20 slightly, or maybe even in a foundations class, and that's degrees and radian measure. So that's where we're going to start. So we're going to look at, that's our title. Okay, now I'm just going to pop open my, on the other screen here, some stuff that we might use, so let me do that. Okay, and then we'll get rolling on. So kind of how I'm going to post this, I'm going to put the dates on. So this is day one of our first unit, okay? So we're going to look at three things today. So what is our goals for today? Is we're going to review radian and radians, sorry, and convert them to degrees. Okay. Okay, and then we're going to look at coterminal angles. That's also something we've done before, or you've done before. Just to review, reference angles, because we're going to be looking at angles in the four quadrants. And then we're going to be looking at the arcs in a circle. So those are the three things we're going to do today. Because we're going to get into something called the unit circle. And the unit circle will be used very often in this class. I'll probably give you a laminated unit circle here in Vanguard, and I'll put one up online for Jordan to print out and use, because we use it as a reference quite often. Okay. So first we'll start with radians. So if I do a circle here, so let's just draw one. And there's my center. And we have some type of an angle in here, so let's draw in a fairly large angle. Okay, and we say that we're going to do the radians measure of the angle. So it has a complete circle here. So if we call, traditionally we like to call the center of this angle theta, like that. This is our arc length along here, so let me just put it in blue. It's been a whole summer since I used my drawing pad, so I'm a little rusty. So this is our arc. Okay, and that has a capital S like this. Okay, and then traditionally this is our radius. So that's our radius in there. Okay, I should skinny that up a little bit. That's kind of a bad writing there.
Cassie to the office, Cassie.
Let's make it skinny. So this is our radius. Okay, so the typical relationship for radians, okay, around the circle, the whole distance around the circle is 2 pi radians around a full circle. Okay, because we know that the circumference of a circle is 2 pi r. and we'll just assume that the radius is 1. That's what a unit circle is. A unit circle is a circle with radius of 1 unit of whatever. Okay? And we'll be using that quite a bit, so that we just assume that r is our 1 all the time. So the number for r that we use is 1. So then if you go 2 pi r, well then it's 2 pi radians all the way around the circle, if it's a unit circle. Okay? So the formula for radians in terms of the arc and in terms of the radius is the radian measure is the arc length over the radius length. Okay? So that means if you have a unit circle of 1, the measure of the radian angle in the middle is the same thing as the length of the arc in whatever measurement you're using the 1 to be. Okay? Because that'll be that way. So this is our general formula. That also tells us, we also know that there's 360 degrees in a circle. So our first relationship that we know in terms of relating degrees and radians together, we know that 2 pi radians equals 360 degrees. Now in terms of radians, if we don't put a unit down, typically it's in radians. Okay? So this would be our relationship. So if we simplify that a little bit, we can divide both sides by 2. We know the relationship is that pi radians is 180 degrees. So a straight line is pi radians, 3.14 radians, if we round it off like that. So this is our basic relationship right here. Okay, so that's one formula you'll have on your formula sheet when we're writing quizzes and stuff. Okay, generally speaking, Jordan, you're new to me. I provide formula sheets for all the exams. You don't have to memorize things and stuff like that. We just be able to use them. So this means pi radians equals 180 degrees. And that's the relationship we use for conversions. So now we're going to look at, in Pre-Cal 30, we do something called exact conversions using fractions and radicals. And not inexact conversions would be decimals. Okay? So the first one we're going to look at is converting, but doing exact conversions or for that. So, and we're going to use this relationship. Now we've done this, or you've probably done this in past math, hopefully. Okay, so we're going to do just a couple easy examples here. So we're going to do radians to degrees. Okay, and we're going to be doing we'll do a fraction example, then we'll do a decimal example in both. So let's say I want you to convert 5 pi over 8 radians. So traditionally, or it might be 5/8 pi, 5/8 and then pi in the middle. 5/8 pi radians, 2 degrees. Okay, so all we do for that is we use the relationship that pi radians equals 180 as a fraction, and then we use this as our radians. So we're going to set up a ratio. Okay, so the ratio that we're going to use is we're going to put radians on top, degrees on the bottom. Radians on top, degrees on the bottom. Now degrees is unknown, so we'll say let n equal the degrees, or d equal the degrees, or x equal the degrees. So I'll say x equals degrees. So we'll put an x here. And that's all we have to do. So then we just do a ratio. Okay? We can cross multiply to get the equal ratio here. So pi times x, and we don't have to estimate the pi because it'll cancel out over here. Pi x equals 5/8 pi times 5 pi over 8 times 180. Okay, so we can cancel pi out on both sides because it's on both sides. And x then is just the multiplication of 5 times 180 divided by 8. Take your calculator out. 5 times 180 divided by 8. If you do that, you get 112.5 degrees. Okay, this time we have you could say a half degrees if you want, but it comes out to exactly 0.5 degrees. Okay, pretty easy to do if you remember the ratio technique. Okay, so that's doing radians to degrees. Let's go the other way and do a degree measure to a exact value in radians, so a fraction value in radians. So doing exact values. We're not going to do a decimal in radians for the first one. So that's our first example. If I go too fast, just let me know. So example 2 we're going to look is we're going to go from, let me go back to typing here. We're going to go from degrees to exact radians. Now there are times when you don't have to do exact values, like with fractions and stuff, depending on how the problem is. They'll usually tell you, or I'll tell you if I make it up. So let's say we want to do 405 degrees to radians. Now it's okay, just call them rads. It's traditional. Okay, so it's the exact same technique that you used before. So we're going to go pi over 180. But this time our x is going to be where the radians are because we're looking for radians this time. Now you don't have to write that. I can understand that depending where you put the x's. And then we have our 405 degrees on the bottom. Okay? And this is the only place where when you're doing, when you want an exact value, you're going to do some reducing into a fraction. Okay, so what do? You cross multiply. You get pi times 405 or 405 pi's equals 180 x's. Now these are both degrees, so the degrees will cancel out, right? So when we divide on both sides, we then have our relationship, 180 on both sides. Now, if you were doing decimals, you could just estimate the pi and do a decimal of it. But since I want an exact value, we're going to turn 405 over 180 into a fraction. So what can go into 405 and what can go into 180 is what you have to decide. We obviously can get 5 in there, but we can probably do a larger number than that. Okay, so whip out the calculator and go, well, let's try 405. Let's try 45. 405 divided by 45. Okay, because I know 45 goes into 180. So if we divide both sides by 45, now if you start with 5 and then you can reduce again. So this would be 405 divided by 45 is 9. 180 divided by 45 is 4. And the pi is still there. So there is your radian measure. Right. 9 pi over 4. Okay. Now, if you were doing that as a decimal, 9 pi over 4, you'd go 9 times 3.14 divided by 4. But often what they want in pre-cal is you to use an exact value of radians. Don't always have to, but so reducing fractions is a skill that pops up quite often. Okay, so that's our first goal basically looked at. Okay, so if we would go back up here, we're just reviewing that. Now we've seen that before in our pre-cal 20 a little bit. Okay, so hopefully that's enough. Okay, we'll go into our second piece now, and we're going to look at standard position and a reference angle. Okay, so this is another review of an important concept, so I'm going to turn my page. Okay, so if we have a quadrant, a 4-quadrant system from a circle, and we just draw it in here like this. Okay, just to remind everybody, typically we use Roman numerals to label quadrants. This is 1, this is 2, this is 3, and this is 4. Okay, and as we go around, if we start on the typical right side here, and we say that this is 0 degrees and 0 pi, or 0 radians, this would be this would be 90 degrees, and 90 degrees is pi over 2 radians, if we have it in radians. So maybe I should put it underneath so we don't think it's 90 pi over 2s. So it's 90 degrees or pi over 2. Now you don't have to memorize that. We'll have a unit circle. And then if we slide all the way over here, this is 180 degrees. And we know that 180 degrees is pi radians. Okay, so another half pi down here would be 3 pi over 2. Or 180 plus 90 is 270 degrees. And then as we get back to here, it would be a 360 degrees as we come back, or 2 pi radians. Okay, so there's our measures as we go around. Now these are right along the quadrant lines. They're very key angle measurements. Okay. All right, so when we do a standard position angle is an angle that has a line right along the positive x-axis and then another line to represent the angle. And we always measure up and around for positive angles, down and around for negative angles. So that's a standard position angle. However, a standard position angle will always have a reference angle to it. So let's do one in the first quadrant. Doesn't matter. The reference angle and the angle are always the same. So we're going to do reference angles. What do we remember about reference angles? Well, those are the angles with the x line in the quadrant. Okay, it's the angle formed by the x-axis inside each quadrant. Never use the y-axis. And we'll say the vector, or ray, or whatever you want to call it. Since I'm a physics guy, it's vector. Okay, so there'll be a line there. We'll do a couple examples. Formed by the x-axis and the vector in the quadrant, in each quadrant. So we'll do an example to illustrate this, and everybody will be like, oh yeah, I remember that. Okay, so let's do one in the second quadrant. Let's say I have this angle here. Let me use an arrow instead of a straight line. And maybe I'll change colors so that we can tell. Let's say that it's this right there. So let's say that this measurement, we'll do degrees rather than radians, just so it's a little bit easier to do the math. Subtract and add from. Let's say that this angle here, which we should do in greens, all right, goes from this angle, there's 90 degrees, and it goes down there. Let's say that this is 159 degrees. Okay, so that's our standard angle, 159 degrees. The reference angle for it is this angle right here, which I'm going to do in green again, but I'm going to skinny it up a little bit. So this is our reference angle. right here. And what is it? Well, it's the measurement, it's the difference between this measurement of the x-axis here and this measurement. So this angle would be 180 minus 59 degrees. So this theta r here is 21 degrees. Okay, and we often use reference angles when we're doing calculations. Now, let's do one in the third quadrant here. Let's say we have, and we'll do it in red. Okay, so let's take and make a little, so let's say that I have, sorry, let's make an arrow here. Let's go back to arrows here. Where's my arrow thing? There it is. All right, we'll make an arrow. Okay, so let's say that this is our one in here. And let's say that this measurement this time, if I go around with my, and go from the positive x-axis all the way around, let's say that that is 224 degrees. Okay. So now our reference angle is here, not here. Okay, don't get confused. Don't ever use the y. So our reference angle in this particular case is still this one, this little one here. Okay, so that we're still dealing with the 180, but instead of subtracting like we did here, we're going to actually start with the angle and subtract the 180. So this is at 224 subtract 180. Well, that's 44 degrees. So our actual reference angle in this case is 44 degrees. Okay, so that's a review of reference angles. Now, the same thing can happen with radians. Okay, so if I said this was, 4 pi, well, it wouldn't be that. It'd be, this would be pi radians. If I said this was 1.6 pi radians, you just take 1.6 and subtract pi from it there. But we're going to just do degrees to start. Okay. Okay, so that's our reference angle. So in this one we were doing 224 subtract 180. This one we did 180 subtract 159 to get our reference angles. We were using this thing. So in here, you don't have to worry about the reference angle. It's always exactly the same in the first quadrant. But in here, you're subtracting from 360. Right? Okay, so there's an example of reference angles. So there was reference angles and degree conversions and radian conversions. So that's something that we've done in the past. So our last and final thing for today, if we look back at our outline here at the beginning. Okay, we did the coterminal angle and the reference angles. Arcs in a circle is what we'll look at in our final area. And then I'll give you some practice you can work on. We'll keep this first period. I'm going to try and keep each of these lessons about 35 to 40 minutes long so that the videos aren't super long. And then I'll stay online as you're working. I'll stop the recording, but I'll stay online in case Jordan has questions, or if you guys have one question, and then I'll answer it, and then he can hear too what we're thinking about as well as a class. Okay. So that's kind of how we'll do it. I'll try not to go really long-winded in the lesson, especially this year. We don't have anybody else to worry about but ourselves. I'm not teaching like the last year where I had a bunch of different maths going on at the same time. So this should be a very profitable way for us to get through it. Now, the other thing that I'll mention here before I leave this is I did everything with positives, right? That's because I went up and around. If I go down and around, that's negative measure. Okay, so if this is 224 positive, then the negative is 360 minus 224. The negative would be that. Okay, But often you don't see a lot of negative angles, but once in a while they'll throw one in to try and confuse you, just to remind us. Okay, so our final piece then is we're going to look at the formulas for radians and circle arcs. We'll do an example of that, and then I'm going to give you some practice. And I know that, Jordan, you already have my email and chat thing, so you can always chat me there. I missed it yesterday, but I got it this morning, so that's okay. You guys as well, I put you in the Google Classroom so that when I put things up, if you miss a day or something, it'll be there. Okay? Everything will be there in case, because not everybody's here all the time, kind of thing, right? And we do have a couple of gentlemen that are taking it later in the day as well. All right, so let's do this last piece. So I'll flip the page here, and we're going to look at using the radian angle formula to do a problem. And this is our last review type thing for today, day one. Okay, so this is just using the angle formula, or sorry, using the radian formula. Okay. Okay, and this is, I'm going to do it in degrees. Remember, radians formula is always in radians. So if you get it in degrees, you have to convert to radians first. So I'll do that type of example. So let's say we have, what is the arc length? In a circle with a radius of 3 meters, 3.0 meters, we'll say. So a large circle, and a central angle of 100 degrees. Okay, so our strategy here is we know that the arc length formula, we can rearrange it a little bit, and we also know that we're going to have to do conversion. Okay, so a couple of steps in here. Okay, so we know that we know that a radian formula is radians equals S divided by R. So if we want the arc length S, we can just multiply both sides by R. Okay, and this is typically how I write the arc length formula for radians, because it's easy to remember, SOR or S theta R. Okay, so there's what we're going to use, but we have to convert 100 degrees to radians. Now this would be a problem where decimals would be fine, because we're going to get an approximate length for the for the arc, pardon me. Okay, so we're going to go and do that first. So if I go pi over 180 equals, we want it in radians, so our x is going to be on the top, and the 100. Okay, so this is one where you can do exact value, or you could do a decimal and it would be fine, because you're going to end up multiplying out to get your S value. I'm going to do an exact value because that's what I'm used to. So we're going to multiply this and say pi over times 100, or 100 pi, equals 180x. So we're going to take 180 out. So this one's easy to reduce. Okay, if you take 10 out of both, you get 10 over 18, and then 2 out of both, 5 over 9. Right? Okay, so let's do that. Take the 10 out. 10 over 18 pi. Take 2 out of 10 and 2 out of 18. So we have 5 pi over 9 equals x. Okay, so there's our do it. Now, if you want to do it in a decimal way, so we'll show it as a decimal. So if we take 5 times pi on your calculator, so times pi, if you have a pi button, you can use that, and divide it by 9, that's going to give us 1.74 radians. .75 radians will go. Okay, so you can choose to do the exact value or the decimal value this time because we are just going to multiply it out with 3 anyway to figure out how many meters it is. Okay, so S then is going to equal our second step. Take our radians, 1.75, and multiply by 3. Okay. So what does that give us? 1.75 times 3, 5.25 meters. So that's pretty much it for our instructional part for today. That's probably my email. Oh, yep, nothing major. Okay, so that's pretty much it for our lessons. So before I go on and give you the practice, okay, so that was about 35 minutes. That's kind of how long we're going to go most days. Okay, I am going to stop the recording here after I give the assignment, and then I'll let you work on it, and I'll keep the video on for a few minutes in case somebody, like Jordan, has a question or we have a question. And then I'll log out about 9:50 or so because I have to get ready for my next class at 10. And that's kind of how we're going to roll when we're doing these lessons. Okay, make sense? Okay, so for practice then, let me get back to my, not that one. I got my day one here. Okay, so for practice, this is in 4.1, we're starting in 4.1. So this is page 175 and 176. Okay, we don't kind of go chapter 1, chapter 2, chapter 3. We bounce around quite a bit. So I'll just give you a few to do. 2, BDF, like every second one there. 3, same thing every second one. Now, if you want to do more because you think you need more practice, go ahead. 4. So the first thing I'm going to ask tomorrow when we start up is, does anybody have any questions about the practice? 5. And 6. Just do those ones. And then 13. AC. Okay, so that's our practice. So I'm going to stop the video at this point, but I'll stay online in case there's some questions as you're working away, and you can just ask me here. But that's our lesson for today. And I'm going to, as you're doing that, I'm going to put this up on the Google site and stuff. All right, good luck.